coordination compounds. Whether I started? Yes. Rules for naming the coordination compound. We saw a few set of rules. Rule number one is what? Always ligand should be named. After the ligands are named, only then the metal ion should be named. This is rule one. What is rule two? If you have more than one ligand, then how will you name them? You have to use the alphabetical order. In that we saw one odd thing, like both are starting with the letter A, aqua as well as amine. In that case, priority is given to amine. So ligand should be named first, after that metal. If you have more than one ligand, then you have to go as per the alphabetical order. If you have monodentate ligands like ammonia, water, chloro, bromo, iodo, then you have to use the prefix di, tri, tetra, so on. If you have polydentate ligands, then you have to use the prefix bis, tris, etc. Then what else we saw? The negatively charged ligand should be ending with the suffix. I think I went to some other point. I'm not referring the fifth point from here. I'm telling point number three. If you have negative ligands like anionic ligands, then you will be using suffix O, right? Chloro, bromo, iodo, cyano, like that. Done. If you have neutral ligands, they have specific names. For example, amine, aqua, carbonyl, nitrosyl, etc. I think the same point, right? Sulfate is also negatively charged ligand, so it is named as sulfato. Chloride is also a negatively charged ligand, so chlorido or chloro. So they should be ending with the suffix O. Okay, now my ligand is over. Then I have to name the central atom. How will I name the central atom? If I have a neutral ligand or a positively charged ligand, then I won't be changing the central atom name. I'll be writing that as such. But if at all my sphere is negatively charged, right? If my sphere is negatively charged, in that case, I need to add the suffix ate to the central metal atom. Repeating point 7, if I have a positively charged sphere or a neutral sphere, no need to change the name of central atom. But if it is a negatively charged sphere, then I have to add the suffix ate. Done. Then the fellow who is standing outside, say for example, the counter ion. If the counter ion is an anion, where will you write the anion? Then he should be written at the end. Say for example, chloride. In many cases, we saw chloride as a counter ion standing at the last. So we will be writing that name at the end because it's a anion. But if you have any cationic counter ion like a potassium, like that, then that will be written first. Okay. So if the coordination compound is accompanied by a counter ion, if it is a cationic entity, then that must be written before the anionic entity. Done. Then oxidation state, that should be written in Roman number. It should be enclosed in a square bracket. So yesterday I think we saw a few examples. So moving to isomerism in coordination compounds. So this is a separate topic but quite easy topic. This is all related to coordination compounds. We have already learned that since different types of ligands are attached to central metal atom, there is spatial arrangement. So there is geometry is possible in coordination compound. I have a central metal atom. Say I have different types of ligands. So there should be isomerisms existing in coordination compound. So what is isomerism before? Two or more compounds having same chemical formula but different structural formula. But that if it is structure, then that is structural isomerism. If the arrangement is different, then it is called as stereoisomerism. So first, what is isomers? Two or more compounds, their chemical formula is same, but their arrangement is different or their structure is different. This is called as isomers. Since there is difference in the arrangement, the coordination compounds exhibit two types of isomerism. One is structural isomerism. Second one is stereo spatial arrangement. A difference in spatial arrangement of ligands around the central metal atom. So that is called as your stereoisomerism. So which two isomerism is possible in coordination compound? Structural and stereo. What is structural isomers? Compounds having same chemical formulae, but they differ from each other in terms of structure. This is your structural isomerism. This is subdivided into ionization isomerism, hydration isomerism, linkage isomerism, and coordination isomerism. And what is stereoisomerism? Having same structural formula, but they differ from each other by the spatial arrangement of ligands around the metal atom. This is of two types, geometrical isomerism and optical isomerism. So this I think we have learned many times, D and L form, then cis trans isomerisms, all these will be coming under the category of geometrical and optical. But this is new to us, right? Under structural isomerism, we have learned few concepts in chapter hydrocarbons and organic chemistry in class 7. Hope you remember. If there is difference in chain, we call that as chain isomerism. Yes, no? But here, since we are dealing with the coordination compound, we have different aspects of structural isomerism like ionization, hydration, linkage, and coordination. Now let us see one by one. What is linkage isomerism? Linkage isomerism is exhibited by coordination compound which have ambidendate ligands. I think you all remember what is ambidendate ligand. They use different elements to bind with the central atom. In that we saw the example nitro, nitrito, cyano, isocyano, sulfato, thio, isosulfato. So these are the ambidendate ligands. So who is going to exhibit linkage isomerism? Coordination compound which have ambidendate ligands. That is, these ligands can bind to central atom by means of different elements. So linkage isomerism is by coordination compound who is having ambidendate ligands. Look at the example here. CO, NH3 5 times, NO2, Cl2. And what color this coordination compound is producing? It is producing red color. And what about this one? This is producing yellow color. Let us have a small thing. Let us try to name this compound like whatever rules we studied yesterday. So tell me, upon ionization, whether you will be getting a negative sphere or positive sphere. Let me come to the main page. Tell me, children, what about this complex? CONH3 5 times NO2 Cl2. Now tell me, upon ionization, whether this complex is a cationic complex with positive charge or anionic complex, or whether it is a neutral complex. Tell me. Fast, fast. Rule first one. First rule, I have to find out what type of sphere it is. Who found? Which is that sphere? Chittaranjan, tell me what kind of sphere is this? Whether it is positive, negative, or neutral. Fast. Devananda, Hansika. Whether it is a positive sphere or negative sphere. Hansika, yes, ma. Try. You may be correct. Chittaranjan is saying it is negative. Hansika, tell me, ma.
Ma'am, even I'm thinking it's negative.
It's negative. You mean to say it will be cobaltate then? Is it so? It is given as CO, right? If you say this is a negative sphere, then I need to add the suffix ate to the central metal atom. So it will be cobaltate. Whether you agree? Yes or no, Chittaranjan? Fast. You said it is negative. If it is negative, should I change the central atom name? I need to change it, right? For positive and neutral sphere, I won't be changing central atom name, but you are telling it's a negative sphere. So should I change it? It is cobalt only, right? So should I add the suffix ate and make it as cobaltate Chittaranjan? Now you want to say it is neutral sphere or it is still you are standing in that point only?
Ma'am, I think it's neutral.
It's neutral, done. It's correct. This is a neutral sphere, fine. So I have to name the ligand. So I won't touch the name of the central atom. I'm going to keep it like cobalt only, fine. So second aspect, what I have to see, I have to check the ligand. I need to name the ligand first. I have two types of ligands. One is amine and another one is nitrito. Obviously, amin's name is going to come first as per the alphabetical order. So pentaamine, nitrito, cobalt, write the oxidation number. And what about the counter ion, ma? Here the counter ion is anionic, right? So it will be coming at the end. So what is the name of this compound? Pentaamine nitrito cobalt, oxidation number chloride. That's it. Fine. So now this the ambidendate ligand present in this coordination compound is going to exhibit a linkage isomerism. In example 1, I mean the compound 1, here the donor is nitro group N. N of nitrito is a donor. In the second example, you see O becomes a donor. So that's what this is an example for linkage isomerism. Done. Let us move to second type of, see, look at the color produced by them. When nitrogen was a donor, then the color produced was a red. When O was a donor, the color produced was yellow. Moving to the second example, we are looking into the subtypes of structural isomerism. We have finished linkage isomerism. Second one is coordination isomerism. So there is an interchange of ligands between cationic and anionic entities of different metal atoms. This is coordination isomerism. Look at the example. Here I have CO, NH3 six times, then Cr, Cn6. Yesterday we saw one example based on this. I think you are remembering, right? We saw an example using platinum purine complex, right? One complex will be becoming positive and next complex will be becoming a negatively charged. Hope you are remembering. Yesterday we exactly saw an example to name the IUPAC of coordination compound. We saw using metal platinum as well as purine complex. This is belonging to same category 10. Now, what is coordination isomerism? There is an interchange of ligands. See, for cobalt, the ligand present is amine. For chromium, the ligand present is cyano, right? What is coordination isomerism? There will be an interchange of ligand between my cationic and anionic entities of different metal atoms. So, what will happen? What kind of isomerism you can exhibit? You can expect here is my amine will go to chromium and my cyano will come to cobalt. This is the type of isomerism exhibited by this type of coordination compound. So, what is coordination isomerism? Interchange of ligands between cationic and anionic entities of different metal ions. That's it. So ammonia went to chromium and cyano went to cobalt. That's all. This is coordination isomerism. Third type is ionization isomerism. So ionization isomerism, from the term only you can get the clue. Which part of coordination compound will undergo ionization? The one which is present outside the coordination sphere. So who will be present outside the coordination sphere? The outstanding fellow, that is counter ion. So here we are going to deal with the counter ion. So ionization isomerism deals with the counter ion. You can easily remember. When counter ion present in a complex coordination compound will be potential in such a way such that it is going to replace the ligand which is present inside the sphere. This is ionization isomerism. Repeating again, ionization isomerism. So which part of coordination compound will undergo ionization? Always a counter ion. So counter ion will be behaving like a potential ligand so that it replaces the ligand. Look at the example here. I have cobalt, amine, 5 times, sulfate, then you have bromo, right? Here, who is outstanding fellow? Bromo. Who is ionizable? Bromo is ionizable. See, this bromo is acting like a potential ligand that what it is doing, it is replacing one of the ligand. See, my bromo went inside the coordination sphere, it has replaced the ligand SO4. So, SO4 becomes a counter ion and bromo becomes a ligand. So, this is called as ionization isomerism. Children, is it clear to everyone? Can I get an yes or no from you people so that I can proceed? Whether you understood ionization isomerism. So the ionizable part of the coordination compound, which is a counter ion, will be acting like a potential ligand in such a way such that it is going to replace the ligand and it is going to come inside the sphere, and the ligand which is less potential than the counter ion will go outside and that will become a counter ion. Is it clear, children? Shall I proceed,
Yes, ma'am.
Bharat Hansika? Okay, now I'm going to ask. This is an open question. Now, the example shown here, I want one of you, to name this coordination compound. I have a central metal atom. I have two ligands here. Both are monodendrite ligands. It's a homoleptic complex. I have a counter ion, which is anionic. I want one of you to try naming this compound. Who will give? Who will give? Mercy is there. Trisha is there. Srinidhi, Karthik, Lohit. Should I call everyone? I don't know what happened to Arya. Arya was there, I saw, then suddenly she left. Maybe she's not keeping well still, or
No,
only
ma'am. She
absent.
said she's having some throat infection.
Okay, whether she's off for all the sessions, no, Ansika?
I think she joins and leaves, ma'am.
Okay, fine. Okay, children, now who is going to try this coordination compounds IUPAC name, which is shown on the screen now? Who will try? Hansika, will you try?
Yes, ma'am. I'm trying.
Yes, ma'am. First to find out whether the sphere is positive or negative. Then try to name the ligand. Go as per the row, as per the rules. I got the name. What about you? You got the name? Bharathan, you want to try? Hansika is trying. Make it fast. We have 4 more minutes. Correct. Chittaranjan, correct. Hansika, try ma. Okay, see, first I have to find out the charge of the coordination sphere so that whether to change the name of central atom or not, I have to decide. That is my point number one. My sphere is neutral sphere. It's a neutral sphere, right? So I will not change the name of the central atom. Done. Then there are two types of ligands whose name should come first. Amin's name should come first, then only sulfato. So pentaamin, sulfato, cobalt, oxidation number or oxidation state, bromine. That's all. Try second one, Hansika. This one. What happened? She's completely off.
No, ma'am. I'm there.
Yeah, ma. Yeah, ma. Try the second one, ma. Where we have changed the ligand and the counter ion. No, try this one. I think you are getting my point, no, children. Then there is no use. You have to apply those rules and try to name whatever the exercise given before. This PPT is already with you, so you need to try naming them. For the sphere is, what about the sphere? The sphere
Ma'am,
is
it's pentaamino.
mm,
Yeah, pentaamino.
pentamine. A M M
Pentaamino.
I N E.
Yes,
Pentamine.
ma'am. I'm just stuck with that bromate thing, ma'am.
Bromo.
It's bromo,
Yes.
cobaltite.
The last counter ion. Tell the name of the counter ion. Sulfate. That's all.
No,
Penta.
oxidation, ma'am.
Oh,
Oxidation.
oxidation number because you have to do it right. For amino, it is 0. For bromine, it is -1. For SO4, it should be -2. So, as per this, you have to calculate x plus 0 minus 1 is equal to -2. Then you have to calculate what is the oxidation number of cobalt. So, it is pentaamine, negatively charged ligand. So, suffix O should be added. Pentaamine, bromo, cobalt, write the oxidation number, then sulfate, because this is also a negatively charged counterion, so it should be named at the end. That's it. Okay, try it. You tried very good. Next, we are moving to solvate isomerism. Next, we are moving to solvate isomerism. This is a very important part. See, this is a special case of ionization isomerism. So, what I mean to say, your solvate is also ionization isomerism only, but it is a special case of ionization isomerism. So, what is exactly the phenomenon? It is based on solvate. So, you are able to understand that it is something related to solution, dissolution. Oh, we are getting the clue. Whether the solvent molecules are directly bonded to metal ion or simply they are present. I'll tell you an example here. See, yeah. Your solvate isomerism is of two types. I said it's a special case of ionization isomerism. There is two aspects. What is that? Whether my water molecule is directly linked to central metal atom or it is simply present as a water molecule. Now let us see the example here. I have a complex here, Cr, 4 times water, Cl2, Cl, then 2 water. Look at the name. I have to name the ligand, right? It is negatively charged sphere, so it should not change the name of chromium. Done. And what about the ligands? Two types of ligands. One is aqua, water, right? It's a special case. So water, and I have chloro or chlorido, both are correct. So tetra. And what about this ligand? This is a monodentate ligand, so I have to use di, tri, tetra, etc. If it is polydentate ligand, then I have to use bis, tris, etc. Okay, done. Tetra aqua dichloro chromium. Write the oxidation number. And what about the counter ion? The counter ion is an anion, so it is written at the end chloride. But you know, the counter ion is followed by two water molecule. It's dihydrate two times. Remember, here I have not written water as di aqua because it is outside the sphere, it is next to counter ion. Okay, right? I'm repeating this point. We let us try to name this compound. This is a neutral sphere, so there is no change in the name of central metal atom. There are two types of ligand. One is aqua and another one is chloro. As per the alphabetical order, aqua should be coming first, and all these are monodentate ligands. So di, tri, tetra, penta should be named. So how many times water is present? 4 times. So tetra aqua. How many times chlorine is present? 2 times. So tetra aqua dichlorochromium. Finish. Then I have to write the oxidation number in bracket. What about the counter ion? The counter ion is anionic, so its name should be going to the end. So chloride. But after counter ion, I have two water molecules, so that is written as dihydrate. That is written as what? Dihydrate. Here, my water molecule is not coordinated in the complex. It is acting like a solvent. So, it is dihydrate. Let us see the second example. In second example also, after the counter ion, children, you are with me, Noma? Everyone are with me, right? Trisha, Deepora, Devananda, whether you all are able to follow this, no children? If you are stuck, please tell me, I'll stop there. Trisha, can you tell me, ma? Shall I proceed, Trisha? Make it fast. This is a record. I'm recording this meeting. Don't drag it. Srinidhi, Satvika, whether anyone can reply me, whether you are able to follow. Mercy, Chittaranjan, Bharadhan. Thank you, Chittaranjan. Only Chittaranjan has replied. Trisha, what about you? Srinidhi, thank you. Trisha, should I proceed or what? Hansika?
Yes, ma'am.
Bharathan, why today no reply? You are not getting the points. Okay. Now, look at the second. Satvika, thank you, ma'am. Look at the second example. In second example, also the complex is a neutral complex. A sphere is a neutral sphere, right? So what I should do, I should not change the name of the central metal atom. Here also I have two ligands, aqua, chloro. So how will I name? Penta, aqua, chloro, chromium. Write the oxidation number and write your counter ion chloride. There is one water molecule. So how they have written monohydrate means what? My water molecule is not involved inside the coordination sphere. It is not involved inside the coordination compound. It is merely present as a water molecule. So its name went at the end telling monohydrate or dihydrate or pentahydrate, right? See the last example. In last example, where is my water molecule? My water molecule is inside the sphere. It is present inside the sphere. It is directly bonded to my metal atom. My water, 6 times water, is directly bonded to the metal chromium. Okay, so what will be the name? I should write the ligand name, right? There is only one ligand. So hexa aqua chromium chloride, that's it. So you understood the difference between hydrate isomerism. First two examples are hydrate isomerism, where my water molecule will not be involved in the coordination compound. It will be present as a solvent molecule. That's it. And in the third example, this is an example for solvate isomerism, because here my water molecule is directly bonded to the central metal atom. It is involved in the coordination sphere. So this is an example for solvate isomerism. Is it clear, children? So we were under the topic of structural isomerism. Under structural isomerism, we saw first linkage isomerism. What is linkage isomerism? Who will exhibit? Only the ambidentate ligands containing coordination compounds will exhibit a linkage isomerism. Means what? My metal atom will be linking to different elements of ambidentate ligand and they exhibit different colors. What is coordination isomerism? There will be interchange of ligands between cationic and anionic entities, right? We saw this example too. Ionization isomerism, my counter ion who is ionizable, he will be acting like a potent ligand, he will replace the ligand. This is ionization isomerism. Then what is solvate isomerism? A special case of ionization isomerism where the water molecule will be simply present as water molecule outside the complex. That is hydrate isomerism. The water molecule will be directly bonded to the metal ion and that is an example for solvate isomerism. So in the three examples given, in the first two, my water molecule is present next to counter ion. It is outside the sphere. So here it is acting like a water molecule. So these two are the examples for hydrate isomerism. While in the last example, my water molecule is directly bonded to central metal ion. It is present inside the square bracket. So this is an example for solvate isomerism. So we have finished structural isomerism. The remaining we can see in the afternoon session. Children, you are able to follow. Now, I just want a few minutes of you. Since nobody has replied, I'm a bit worried.